G'day guys, Matt from Hal Heavy Duty. We're an Aussie machine shop that specialises in the drilling industry. We fix all the gear that drillers break, which is constant, and we also make all the crazy custom gear these guys need to get the holes dug. Now in today's video, we're going to be making a set of jack leg clamps. So what happens when a rig goes out to site, they'll find where the pad, usually X marks the spot, and then they have to level the rig using a set of 4 hydraulic jacks, one on each corner. These clamps then get clamped once it's in position so that it can't subside. Now we're going to be making these manually in the big green Megabore Hulk, but before we do that we've got to head outside because there's no drawings or plans for this. I actually have to just copy the thread off a jack leg and get all the thread depths, and I'll show you how we do that. So let's get stuck into it.
Alright, so as we head out to the rig here, you can see my large set of verniers and bits and pieces with me. We've got to copy this thread here. That's the male thread. I've got to make a female to go around that. It's a clamp. I'll show you exactly what it looks like in a second. But to copy this thread, I really just need a few things. I need the outermost or major diameter, I need the thread depth and the pitch. And with that, as long as I know the type of thread that it is, which in this case it looks like an Acme thread, I've got a few different inserts that we can try to get the exact size right. You can see that's 215 millimeters. So 215 you can see written down there, which is about 8.5 inches. The thread depth, we're going to use a little modified gauge there, and the thread depth is 5 millimeters. So with that, now all I need to know is the pitch. So let's find that. When it comes to checking pitch, first thing I need to know is it imperial or metric? We have a bit of a mix in the shop. Now this is an Italian drill rig, so my money is that it's going to be metric, and judging by the size of it, measuring from crest to crest, it's got a pitch of 8 mil. So the best way to check that is to go across 2 or 3 threads and see, does that hold up? So if I measure one from crest to crest, it will be 8 mil, which it is, but some of the imperial and metric threads can be deceivingly close. So I want to measure it across 2 or even 3 threads. And when I do it across 3 threads, you can see it measures 24 mil there. You can see that measures 16, and then one more, it'll come in at 24, which is just bang on, meaning that's what we've got to do. So perfect, you can see it right there, 24 mil. And now all I've got to double check is, does the insert fit correctly? Like, is it actually an Acme thread? Which it is. So we're good to go. Now I'm going to head back inside here and we're just going to do a quick design up of what the thread needs to look like. So we've got all our basic dimensions there. First thing I need to figure out for doing the female, or the box side of this, is what is the bore going to be. The bore will be 215, which is your major diameter, minus twice the thread depth. So that would be 205, but I actually want to put a mil of clearance in there, just because it's going to be out in the field and it needs a little bit of wiggle room, we'll call it. So 206 will be the bore, and then once we've got that, it'll be just cutting the thread with an 8 mil pitch to a depth of 5 mil. So we are good to go with that, nice and simple. This is the bit of gear we're working with. So on the left there is a set of these that already exists. It's actually just easier to copy the male thread rather than trying to copy the female that you can see there, the yellow one. Now we've got a set of 2 here, older ones from a different rig that aren't currently being used. So we're going to just modify these by putting them in the big lathe. We've welded a piece of pipe on here that you can see just to make it easier to grab them for when we're turning it. It gives us a little bit more room to pull up when we're threading as well. And of course there's a bloody mud wasp. I don't know if any other country has these, but the bane of my existence. I'm looking forward to destroying that. Anyway, we're going to pop them into the 4-jaw here now, into the Hulk. The sound of this thing starting up is one of my favorite sounds in the whole shop. You just wait for it. All right, so first thing we're going to do is bore this out to 216 mil, including getting rid of that filthy mud wasp. We're going to use a 40 mil WNMG bar to do that. Interrupted cut to start off with, so we will go a little bit slow, and I'll just let you see how it all comes together. Alrighty, so we're going to use a top-notch threading bar just because that's the insert that we actually have to suit this, is a top-notch insert. We do have a few different sorts, but most of the stuff we use is Kennametal. Quick final measurement check, and we're just going to do a feather pass here just to check that the pitch is correct. So with the Hulk, you actually have to set it all up with all the gears in the back to make sure that it's correct. It's not like a more modern machine where you can just select a few levers. So we always want to double check. I believe it is pretty accurate just from looking at it, but we'll double check before we do it. Before we finish threading and then testing the jack leg clamps, I just wanted to show you a couple of the other things that are going on in the shop at the moment. So young Willie has been blasting out a few casing lifters on the mill here. These take a lot of work, but they have to be made out of a single piece of 4140 steel just for the lifting requirements. So we've made 2 of those up. They're for pulling casing. Got a little, we've just reconditioned what's called a little hall plug. So these are the sort of things that we make pretty well all day long. My favorite bit is actually taking the tape off. I know it sounds childish, but I just love the finish that it comes up with. And all of these are currently painted. We're looking at getting a finishing system called manganese phosphation, which I'm looking into at the moment. But for the minute, most of the things just get given a good coat of paint, and we then use a process called Defense Yellow, which is, it's actually an Aussie-made product. It's bloody amazing stuff, but we use it on all of our threads, and it just stops them from rusting. It's magic stuff. So yeah, this is just some of the stuff that we do in the shop. Got a couple of other little drive head adapters here. That's all made out of one solid piece of 4140 steel. That was done by young Ronnie in the CNC. He's bloody fantastic. Knows his stuff back to front. But yeah, these are the sort of things that we're doing. So I'll show you some of these in future videos as they come up. But I just thought I'd give you a look at some of the weird and wonderful things we make for drillers here. I'm also in the process of setting up a brand new HTS drill. This is for making non-return valves for the drillers. And this thing is wild. So if you're not part of the channel yet, make sure you subscribe because we're going to be running this next week and it is ballistic. Check it out. Back over in the mill, Willie's making one of the essential parts for a 3-meter casing lifter. I'll show you the diagram of that in a sec, but he is getting some really good experience, and at 16 years old, young Willie is just an absolutely invaluable part of our team. We've got a really good team in the machine shop, but young Willie's rock star at the moment. So this is the part that he's actually working on. That's going to be used to lift up, as I said, 3-meter diameter casing. And the little green part there is what Willie is actually working on right now. So he's just setting it in and using a dial indicator to make sure it's running true. Good practice, you know, to be able to set things up absolutely spot on, but he does a great job. And Heath, who runs the Hulk, our big green machine most of the time, he does a great job working with Willie. These 2 guys, young Willie is going to be one heck of a tradesman, and you know, Heath's very, very good at working with him. So as I said, we've got a great little team, and I'm very lucky to be working alongside these gentlemen. So you can see our cutting edge engineering style blocks there. That's an idea from Curtis that we just use all day long for what we do. So again, big shout out to you, buddy. If you haven't seen his video on that and you've got a machine shop, you want to make a set of these. They're awesome. We've found for maximal metal removal, like what we've got to do here, a 50mm cutter with 3 teeth. So a low pitch cutter, we can absolutely blast it out with our mill Godzilla. It's a quantum bed mill, but he's taking 8 to 10mm depth of cuts there at about 1200 RPM and just smashing it out. So we found that that's better than using a big cutter head, just getting in and absolutely nailing it out. And you'll just see just how quick he is in this little video here. But yeah, this thing just sounds like a machine gun going off.
Great job again, Willie.
Nothing.
Leave your hand. Oh. What the? All right, we're going to drill it out with a 50mm indexable drill now, and then we will use an indexable head to get it out to the desired 77mm. We just don't have, we have a 78mm drill, U-drill, but that would be oversized, so we'll just stick to this. And I love watching these because to me it reminds me of those things in Vegas where you see like the money that just keeps pushing to the side and you're waiting for it to fall off. I don't know if that makes sense, but that's what it reminds me of watching these U-drills. So we'll get that to size and then we're going to actually shape it in the saw. All right, there's still quite a bit of material to come off here. So rather than trying to set it up and mill it, we're actually just going to use the saw here. So I don't know if it's going to fit in our saw, but let's go and find out. We'll set it up and fingers crossed, because it'll save a lot of time. So we've gotten over to the saw and we're about 5mm, like a quarter of an inch. A quarter of an inch too big. Just not quite. But what I'm going to do is there's always, where there's a will, there's a way. So we're just going to take off this little plate for the vise here. You can see just there, I'm going to take that little plate off temporarily. Just a couple of countersunk hex head screws are holding that in there. So we'll take that off and that'll give us the extra bit that we need. Now I'm going to level it using some jack bolts. We'll just stick those underneath to make sure it's absolutely spot on. One thing we've found is trying to cut really straight with this saw, because it's not the straightest cutting saw, is if we just back the feed right off, it tends to cut pretty well. Well, that's going to get sent over to the boiler bay because the rest of that casing spreader bar will actually be made over by the guys in the boiler shop. So that'll go over to them. They'll finish like shaping it by hand. Happy days. Really did a bloody great job on that. Another little side job that happened this week
is the smaller of the two 4-jaw chucks for the Hulk. Actually, when we purchased this machine secondhand, the chuck actually had a crack in it. So these two parts were actually falling out. They had held in, but we just decided, look, just safety wise, I want to get it repaired. It was still working okay, but they weren't fully secured in there. This is just for the rear chuck, so I'm okay for us to give it a go at repairing it. We do have some very, very skilled boilermakers, so we're just going to see if they can put a repair onto this, because it's about between $16,000 and $20,000 for a new chuck, so I'd rather just repair this one. We'll see what they can do, hey?
But, yeah. I'll get it.
Try to burn it in, eh? What sort of rods are you using?
High nickel. I don't know what they call them, I just know they're high nickel rods.
High nickel, yeah, right.
Yeah.
You're picking up some more tomorrow?
Yeah. I'll get you the name of them in the morning.
Yeah, that's cool.
So it was a cast steel chuck, and he used a high nickel rod to lay the base and then finished it with stainless. So it was all preheated, and he's done a very, very fine job on it. As I said, this is a secondary chuck. I wouldn't use it as the primary front chuck for the Hulk, but it will be just fine repaired. Considering it just made 60 rods with the brake in it, this is a huge improvement. So I consider that a win, a $16,000 to $20,000 win. Geez, they did a nice job on that. Very happy with that.
What do you reckon?
And whilst we've got it pulled off, Heath's going to give it a bit of a service and clean, and just make sure that if there's any little burrs or anything, we'll just give them a little filing down and stone it all out. But I'm very happy with how that came out. So that will now go back on as the secondary chuck on the Hulk and live to spin another day. Alright, we're back full circle to cutting the threads for these jack clamps. Now I'm going to do a time lapse so that you can just see how long it takes to cut these when you do it properly. That's in my opinion, because if we go too fast, you end up with chatter. If we cut too deep, it ends up taking a lot to actually finish it off inside. Even when you do finishing passes, I've found if you just take gentle cuts at a relatively slow speed, it might take you a little bit longer to cut the threads, but the finish is always really nice, and you tend to break less inserts. I can't take credit for this one actually. Heath did 90% of the work on this. I was just taking over while he went to the loo for a sec. But they came up beautifully, so well done. Now we're just going to head off and test them and see how they fit. My prediction is going to be spot on perfect. Look at that. Beautiful. Lovely. That's how they should be, where they can just tap on, tap off, but not too tight.
Penny, Murray, buddy. What's happening, buddy? Hey, mate. Come here, bud.
Sit, buddy.
Hey, buddy. Oh, yeah. Hey, buddy bear. Oh. And every time you pat him, there's a huge cloud of dust that comes off him. He's an escape artist, so we're in about a 5-acre yard here. And if there's a way to escape, oh, Murray's going to find it, aren't you, mate? We've thought about tying a piece of poly around his neck, but we don't. We just play the constant game of catch and release, don't we, buddy bear, hey? We just want to escape out everywhere, hey? Yeah, everyone loves him though. He's a good boy. So one of the things we've got here, this is actually where my grandfather used to spend a huge amount of his time, which was out here repairing drill bits. Repairing when these PCD buttons actually get destroyed or chipped off, rather than throwing away a whole drill head. For years we just, like that there, you can see that, that's going to need to be replaced. So we can replace them and we just get so much use out of one drill head rather than treating it like a throwaway item. So that's one of the things that we will do together very soon. Yeah, but I used to drive in here as like a teenager and a kid. You'd come in through the gate and you'd always know if Granddad was here, because he'd be out here just working away. He just had a wonderful way of just getting into like the rhythm of work. Like he worked, my grandfather Hal, he worked until he was 87 years old, and I'm pretty sure my dad will do the same, and I'm pretty sure I'll do the same, because we actually enjoy working. Like, he just loved it. He loved going to work. He'd been working since he was 13 years old. But this is what he spent a lot of his time doing, cutting threads manually and repairing all the busted drill gear. So I feel pretty lucky that I get to do that sort of stuff now. Give you a little size perspective, I'm standing inside the MEGADRILL itself now. This is the mid-size, so 2.7 meter shroud. I can't even touch the top of it, really. The bit itself, so this is one of the 3 different shrouds, just for a size comparison. Right. We're basically building a drill out of a skateboard ramp. I never thought I'd be able to stand inside a drill bit, eh? It's just wild. When they said they were doing a 3 meter drill bit, I genuinely thought they were joking, because when I was working as a Boilermaker, the largest one I'd ever worked on over in the fab shop was a 1.6 meter. And that felt massive. Now it looks like a kid's toy. It's amazing how just the size and scope of everything continues to increase around here. And there are rumours, just rumours, of a 5 meter drill bit possibility. So I don't know how the hell we're going to do that, but we'll find a way. Well, I'm really happy with how that turned out. They fit beautifully. They're now off to get painted, and then they'll get sent straight out to site, because they are currently setting up the big rig. Bit of a time frame for you. It's going to take them a couple of weeks to set up and test everything, and then the pilot hole will get dug, which it's all being tested. It's the first time this rig's been run. So a bit of patience from everybody. You are going to get to see it all come together. They're going to dig a pilot hole, then put in the big auger so that they can put in the monstrous bit itself, and then that MEGADRILL's going down to 250 meters, and you are going to get to see it. So if you want to be part of our little project of what we're up to and just get a window into our world, don't forget to subscribe to the channel, and if you enjoyed the video, don't forget to like it. Anyway guys, I will see you in the comments, and I'll see you on the next one.